So what are we actually going to talk about here today? I'm going to just go through a couple of the topics. We're going to talk about some of the challenges you might face hosting your games using the cloud. Who's Multiplay? Some of you probably haven't heard of us. Why do we use hybrid scaling? What is hybrid? Why is it a thing? What are the challenges you're going to face when you get some auto-scaling? And what are some of the success stories you've heard? So I'm very pleased to be joined by Gill from EA. He'll be talking to you after my presentation. And I really want you today to leave with a better understanding about how hosting a AAA multiplayer experience works and how some of Multiplay's products could help you do this. So who are Multiplay? So Multiplay joined the Unity family back in November last year, and we're really here to help bring the power of an enterprise solution to connected games all across the globe. So that's us. Let's get a sense about some of you guys. So hands up in here if you've shipped a multiplayer game before. Oh, good, a few of you. How many of you are working on one right now? Good. So for those of you who haven't shipped a multiplayer game before, I'm afraid I've got some bad news. Real-time multiplayer games are hard to create and they're hard to operate. So as some of you would have heard in the keynote on Tuesday, they're quite not difficult just to create, but actually look after once you've shipped them. I personally have shipped about 100 different multiplayer games, so unfortunately I'll tell you this is true. And even the AAA publishers out there in the world, they might only do 3, 4, 5, 6 multiplayer games in a year. Multiplay tend to ship about 50, to give you an idea. So we've been around the block for a while. We've been around 20 years. We've shipped a few games. Some of them you will have heard of. And here's our experiences. So to help set the scene, I just want to talk a little bit more about some of the challenges you're going to face and what do we actually mean by a hosted real-time experience, and what are some of the challenges that you used to face but maybe not so much anymore. So dedicated servers, that's the first thing I'm going to explain. So for those of you who don't know, a dedicated server is typically using a headless version of the game engine to behave as a server. It just transmits enough data about the state to clients so that they can maintain their own version of the game world. And it's really responsible for receiving and processing player input and being authoritative on a lot of the decisions that are happening in your game. So why do we think dedicated servers are really good? So ultimately, they're the best experience for players. So for those of you who have shipped a peer-to-peer game before, you know that you have to deal with a lot of consistency problems. So maybe the player that you choose as the host on a listen server might have a bad connection, or maybe you're going to have to transverse firewalls, or you're going to have some problem where the host disconnects and you have to do migration. All of this is solved by using a dedicated server somewhere out in the server infrastructure. Also, you can host some larger sessions. So for those of you who might be thinking about making a battle royale game, I'm sure there's some of you out there, unfortunately, you can't do that in peer-to-peer. You have to go for the dedicated server model to hit kind of anything above about 16 players. Your bandwidth particularly is kind of an n-squared problem, so using a dedicated server can kind of help with a lot of that. And there's security. So if you're not making a server authoritative game, if something is client authoritative, they can just change what they're telling each other. They can just go, oh yeah, I definitely hit that guy. I totally shot him. And then the server will go, well, no, you didn't, and roll back. So all of this kind of helps make a better player experience for the players, but we think it's better for developers out there too. So one of your key things, particularly if you're ever going to ship on console, is that you can iterate way faster using a dedicated server model. We always tell anybody we speak to, and Respawn and EA are no different, that you should move logic from your client to the server as much as possible. And that means that if you want to make some changes to your server, you can simply just deploy them nice and easily and get them out there. And actually, this means that you have to go through cert process less. So anybody who's used to doing first-party certification, you know it's an interesting challenge. So if you're just patching servers and just doing a quick logic change server side, there's no problems there. Just get it out there. Don't need to cert. So back in the olden days, you wanted to do some game server hosting. What could you have done? What might have been your downfalls? So traditionally, you kind of had 3 main ways of doing things. First up, you had co-location. So by co-location, I mean that you would go find some space somewhere, you would buy some servers, you'd maybe lease them over 3 years, put them in a facility somewhere, connect them to the internet, all that kind of stuff. Your problems with this is it's a long lead time. You typically need months to kind of build out a data center presence like this. It's inflexible. Once you bought it, you've got it for 3 years. It's going to be there. If you don't need it, tough luck. If you need more, it's going to take you a while. And you need people on the ground to go physically touch those servers every time there's a problem. Overall, not a really great experience for a games developer to be doing. So what if you went to a data center company and said, hey, can I lease some hardware off of you? Well, it's a good option, but quite often you need to have quite complex vendor relationships. If you're going to ship a multiplayer game in, say, 10 locations worldwide, and that might mean up to 10 different vendors, 10 different support contacts, 10 different legal processes, 10 different bills, and that's kind of quite difficult, particularly for the smaller studios. And for those of you in larger studios, maybe your procurement process would be tricky to do 10 procurement processes. And they still want you to commit up front. Even if you're leasing this stuff at a month at a time, you still have to commit up front for whatever the hardware is, and it can be a little bit slow to react. So there's this wonderful thing called the cloud. I'm sure you've heard of it. So the cloud fixes a lot of these problems, but ultimately you get the flexibility, but you have to pay for it. So if you're going to be able to ship your game and you'll get a nice scale up, great. Cloud will scale for you, still get there, but you're going to pay for that kind of flexibility that it offers. And unfortunately, as we found out, as much as they might tell you otherwise, the cloud is not infinite. We've had multiple AAA launches that have run out of hardware on launch in cloud partners. So what does this actually mean to you, to the players? First up, it's really hard to predict your hosting ahead of time. If you've got a crystal ball, please tell me. I would like to buy it off you. But do you go ahead and over-purchase? Say you think you're going to hit 10,000 players on day one. Do you go by 20,000? But you're going to be wasting your resources. Or even worse, do you then try and nail it exactly? You say, hey, 10,000 players, that sounds about right. Then 20,000 show up. That will destroy your launch. You will never get those players back. They will be gone. They'll post angry things about you on Reddit. And you only get to launch once for most titles, so get it right. So again, use the cloud for that, but you would pay for that flexibility. So can you actually afford for your players to turn up? That's possibly the worst thing you could do. So I've talked a bit about some of the problem space here, but who are Multiplay in this context? What can we do for you? So these are some of the ways that we've kind of fixed this problem. And I'll tell you a bit about what our product offering is and how it helps mitigate some of these problems. So first up, we've got flexible infrastructure. What I mean by that is we have a hybrid, i.e. bare metal and cloud, auto-scaling infrastructure. We have a whole bunch of management tools around there doing automated patching, templating, health monitoring, all of that kind of stuff and more. It's all backed by a premium support team, 24/7, 365, biggest companies in the world using these guys to help keep their game alive. And even our most junior staff have got years of experience in shipping multiplayer games. And great, all of this is accessed by one API. So you want multiple cloud partners, you want bare metal, you want hybrid. Great, same API setup, one set of integration, you're ready to go. And this might seem a bit odd to some of you, but you get one bill at the end of the month. So if you're in a large organization and you've ever had to go through this kind of procurement process, you'll know that one vendor and one bill is actually a bonus. And as I kind of say, Multiplay only do games. If you want a website hosted, sorry, that's not us. But games, we know them through and through. So we actually work on any engine, not just Unity. We're completely engine agnostic. We work on any platform, PC, console, mobile, whatever it is, whatever you fancy. And we're multi-cloud, but we really work quite heavily with Google Cloud, as some of you would have heard in the keynote. We also work really closely with them. Again, your games are 24/7, 365. It's no matter if you're a one-man team in Southeast Asia or you're 100 people in Europe. It doesn't matter. Gamers are there 24/7. So you need somebody looking after your game 24/7 if it's a live online multiplayer title. And do you really want to get paged at 4 a.m. on a Sunday? I don't think so, but please tell me if you do. And global coverage is kind of hard. Not only do you need ops people around the globe, but you actually also need to go make sure that your hosting is close to your players. So if you're making a latency-sensitive game, particularly a shooter or something like that, you really want to make sure that the players are getting a great experience no matter where they are in the world, and that you're grouping local players on local servers. So typically you would have had to have gone to multiple vendors, multiple cloud partners, but we're a one-stop shop to hit about 95% of the globe. This is some of the places that we are in the globe, but as you can see, we've got a pretty wide spread across where most gamers are. So our tech's proven and kind of trusted. We've been around for a few years, as I kind of mentioned. Here's some of the games that you might have heard of that are using our solution. We don't just do AAAs, although that's what I'm talking about today. We do indie games as well. Here are some of the ones you would have heard of. But the one thing that they all share is the need for an enterprise quality solution. So all of these are live games right now, 24/7 across the globe, all using Multiplay's tech. And no matter kind of what team you are, what size you're doing, if you're making a real-time online game, this is some of the stuff that you're going to need to think about. So that's kind of what Multiplay do. I want to deep dive on a couple of topics now. I won't cover everything, so if you have questions at the end, please hold them right to the end, and then we'll go through them. But one of the most important things I want to talk about is hybrid. So this is something that really is quite different about how Multiplay look at the problem space. And if you think back to my earlier slide about kind of wasted players, here's kind of what happens in hybrid. So just to quickly cover off, hybrid means you have a static amount of bare metal that changes every month, but static at the start. Then you just burst into the cloud every day that you need it, per region, per area, on demand, bursting into one or many clouds. And it really means that on launch day, you don't have to take the risk on prediction. You can put in a safe amount of bare metal and just let the cloud handle it. And then once you know how many people are turning up every day, you can then kind of refactor your bare metal, get it into an optimal solution. Bar the clouds running out of cloud, all of your players are going to get served. So there's no risk of day one of somebody turning up and hitting in like an error 25 or sorry, there's no server capacity or like a 20-minute matchmaking time or waiting for that kind of problem. The hybrid solution means that you kind of get the best of both worlds, and really you're optimizing for cost. So all of this stuff about it being hard to create and operate games, it can be expensive, but if you pick the right solution, you can absolutely make a success making real-time games. So the other kind of thing that I like talking about is redundancy, so provider redundancy. This is Johnny, one of our technical account managers, who is in the audience in the back. He really likes this photo, so I put it in every deck. So here, this is actually the launch for Titanfall 2. This is the war room. The internet's unreliable, and it's full of nasty people, unfortunately. And some of them are going to play your game, and some of them are going to try and take down your game, and it's a fact of life, unfortunately. So here's an example where during the launch of Titanfall 2, one of our data centers got hit by a DDoS, not aimed at us or Respawn, but another customer in the same facility. And we were able to kind of migrate between data centers in real time. And if you have a close look at the graph, you can see us moving from blue to red, and then a little bit at the bottom right to kind of burst up into the cloud to cover off the difference. So this was all fixed in about 10 minutes, and it was actually one of the biggest DDoSes of that year that hit the data center. Rather than kind of having to take players offline or push them to another region, we just simply flip between two data centers in the same area. So players might have got disconnected once, but other than that, they didn't notice. So scaling. I've talked about scaling. Great. Match all your players. So one of the things is that scaling up's quite easy. You just throw money at the problem. Even if you just need some more space, you can just spin up more. Even if it's manual, you're sat there on a command line saying, more VMs, please. You can make more VMs. That's not too hard. Your real problem is actually scaling down. So when it comes to 2, 3 a.m., people are stopping to play a game, they're going to bed in that region. You want to get rid of some of these VMs. You don't want to have to leave them up and paying for them. So how do you get to a point, and you need to think about this as you architect your design in your game, how do you get to a position where you're not leaving one player on one VM? So say you're using like 32 core VMs, and you've got one guy sat idle at the end of a round or something. Do you really want to be paying for a 32 core VM to run one person who's sat there AFK? Don't think so. So one of the things that Multiplay do is that we, because we're in control of where we put players, we understand when we want to destroy VMs. So we will actively push people towards VMs or towards hardware that we're going to keep for the rest of the day, or onto bare metal, as the case may be, to kind of optimize this problem. And not only is it kind of a poor player experience if you end up with like half full games on servers, but you're also going to be it's going to be expensive. You don't want to pay the money. So make sure you're considering fragmentation in your middleware or with any hosting provider you might work with. So I've talked a bit about some of the problems. How do you know if you've got a problem? You kind of need to be able to see this kind of thing. So it's not just about how much instance costs to run, or how much bandwidth the players are going to use, or how much that VM actually costs you, but how efficiently are you using your VMs? So here's an example of a game that we've worked on, and this is what a good game mode looks like. For those of you who can't see the graph so well, there's about a 75 to 85% density. And what I mean by this is that, say you've got a 32-player server, I mean that out of those 32 slots, when a game is going on, you're using 75 to 85% of them. Considering that servers are going to be empty for a while you're doing matchmaking and while they're cycling in the game, this is quite good. Now, unfortunately, sometimes games look a bit like this. So this was a game mode specifically that had 23 to 50% density. And what we found is that they were getting servers of a certain size and only filling them with a smaller game type. So whilst they were reserving the instances for a nice large game type, they were actually only using them for fairly small matches. If you do the math, 50% efficiency, double your hosting cost. Not great. So what happens if you fix it? So this is actually an example of where we worked with one of our partners to kind of help them here. And they went from a 38% player density up to the tops of 90, just by making a couple of changes to their matchmaking algorithm. And as you can see, the capacity line, the blue line, that came down by over 20%. So actually here, that was actually a really significant cost saving for the developer. And this is an insight that we really were able to give them by looking at this kind of specific problem. So it's not just about your VMs, how well they're performing, are you doing okay on CPU and RAM? You should do that. But actually, your architecture as a whole, how efficient is it? What are you doing? How are you using it? How are you consuming the resources you're using? So dedicated servers, you got to a position now where you can iterate really fast. Great. How do you get the files on the boxes? So some of you who've done cloud setups before, maybe used to creating a new AMI or a new setup, destroying your whole VM environment and bringing them back up. You can do that. It's pretty bulky, and you generally have to spin up kind of twice as many VMs as you need. But also, you've probably got some bare metal if you're using hybrid. You also need to kind of patch these files. So what Multiplay do, and this is an example of Titanfall2, is that we just run all of the files side by side on disk, and we can seamlessly kind of, without impacting hardware performance, we will on the fly stream across new builds to this hardware, and then we go, okay, great. It's a new build coming along. All we need to do is that the matchmaker just starts asking for this new build. And then as you see here, kind of the servers just steadily switch over to their new builds, moving into version 2 here. And it doesn't matter if it's PC, PS4, Xbox, whatever it might be. You get a nice slow kind of rolling process as the matchmaker requests it. So we kind of call this zero downtime patching. If it's a server-side change, your clients will literally never notice. They'll just come out of a session, play another session, end up on the new version. And here's kind of what it looks like in kind of a player graph over time. And this is a Titanfall2 patch. You can see kind of steadily migrating from one build down to the bottom, and then the other build coming up. And the only decrease in players here in the middle was that there is a client patch at the same time, so they hopped off, downloaded the patch, came back straight away. So there's no more, oh, at Tuesday at 6 a.m. we're going to take down your realm for an hour. This is live patching in action. Players should hopefully never notice. So this is all good, talking about all the nice scaling and patching and everything else, but what about your cloud partners? So obviously you heard from JR on Tuesday that Unity's got a great new partnership with Google Cloud, but even at Multiplay, we've been partners with Google for many years before this, before we were acquired by Unity. And we really chose them for our primary cloud provider for Titanfall 2, but why? So here's a good example of a Windows setup on Google Cloud. So it took about 3 minutes to create a VM, about 1.5 minutes to boot it. Unfortunately, 95% of that is Windows being slow. Don't make Windows game servers. And then it takes about 3 minutes to shut down. And the key thing here is that you're billing in 1 minute increments. So you just pay for the first minute, 1 minute increment after that. So if you want 11 minutes of a VM to run a 10-minute game session, great, go for it. You'll pay for your 10 minutes. One of the other partners that we work with, they take about 9.5 minutes to create these VMs, about 1.5 minutes to boot them, and then, again, 1 minute to shut them down. But the real killer for Windows on this partner is that they bill you for an hour up front and then every hour. So if you need 10 minutes of a VM, that's an hour. You need 61 minutes of a VM, that's 2 hours. So unfortunately, you have to be really, you have to change the way that your algorithms work based on billing methods of your cloud partner. Google Cloud, we're quite happy to shut them down nice and early. The other partners, maybe we'll hold on to them for a little bit longer. And really, consistency is important too. So Google are super consistent. It's 3 minutes to create a VM if it's midday on a Monday or 4 a.m. on a Sunday. It doesn't matter. It doesn't matter where you are in the world, where it is. That's consistent. And when you're doing scaling, having nice, fast, consistent deployment times and creation times mean that you only have to predict 4.5 minutes in the future, not 20 minutes in the future. So you can create a nice little thin buffer over the top without having to kind of overspend and over-provision. So here's some of the success stories. As you can see, this is a day of Titanfall, just scaling up in all the regions. But we've done other games too, with different regional splits, like Killing Floor 2, and some of the other games you saw earlier. And we're working on loads more out there. So for example, with Killing Floor, they're still using the power of the cloud every single day. They scale up. No intervention from Multiplay. Tripwire never have to speak to us. Right now, there will be a cloud somewhere hosting this game. It just works. So hopefully this is some useful information about Multiplay. If you want to know more, we have a kiosk out on the booth, on the show floor in the middle. You can visit our website. There's plenty of information on there. Drop me an email, drop me a tweet. Also, we're hiring more developers back in the UK, so if you're a Golang programmer, please come talk to us. We would really like to talk to you. And there's plenty of other kind of roles on there. And so that's the end of my section. I'm going to hand over to Fred now. One thing I will ask, just hold any questions till the end and we'll go through them together. But let me just swatch decks and I'll hand you over to Fred.
Interview.
Yeah.
Cool.
There you go.
Ooh.
Over to you, Fred.
Morning. This is a take on a talk that John Shiring, otherwise known as Slothy at Respawn, wrote and presented back at GDC last year. It's my take on that from an EAP perspective. I'll explain what EAP is in a minute. There's a very small ops team at Respawn, 4 to 5 people, that worked on all of the online systems and maintained the online systems for Titanfall. Great team. Slothy heads that, but there's a shout out to Mike Kalis, Roger, and Hoff, who also work in that team, because they create a lot of the tech that I'm talking about today. So what is EAP? EAP is EA Partners. We work with third parties to bring their titles to market with EA as publisher. Started way back with DICE and Battlefield. Then we acquired them. We've worked with Crytek on Crysis 1, 2, and 3. We worked with Coldwood on Unravel. More recently, we've shipped 4 games this year. Faye on Unity, Burnout Paradise on an EA custom engine, A Way Out on UE4, I'm not sure I'm allowed to say that here, and Unravel 2 on Fire Engine, which is Sony's engine. We've also worked with Titanfall and Respawn since 2013. EA Partners is always looking for great games, and Matt Dixon at EA Partners is the Director of Business Development. We're reviewing games continuously. We've also got Sea of Solitude, which is coming out on Unity next year. So if you're interested in a publisher, please contact Matt. I'll give you some basics of Titanfall 1 and 2. Respawn came from Call of Duty. At the core of the team that created Titanfall were the Call of Duty team. Call of Duty was what's called peer-hosted, and I'm repeating some of Will's messages because they're very important messages. We have colluded on our talks, but there's areas where we wanted to stress things, so we repeat them. One of the conscious decisions that Slothy made when they started on Titanfall was that they were going to be dedicated servers, not peer-hosted anymore. One of the reasons for that, which is the bold one at the bottom, is that you have limited player counts on console. When we were working on Crysis, for example, the console versions which were peer-hosted could only support 12 players because the PS3s were maxed out at that, whereas PC shipped with 16 because it had dedicated servers. The CPU and memory should not be the limiting factor to your game. The limiting factor should be whether it's fun or not. And Respawn didn't want to be constrained by the number of players. Ultimately, Titanfall actually plays mostly 6v6, but there are modes which are 12v12. Potentially that could have been peer-hosted, but there are lots of other reasons why peer-hosting doesn't work very well. You've got connection quality when somebody's hosting it at home. How good is their bandwidth? How good is their router? Is it stable? Firewalls get in the way. Can they see all the other players, depending on your network architecture? The host usually has an advantage. If the host knows they have an advantage, they can cheat. The host can grief quit and lose everybody's game. If they quit, how do you migrate to another host? These are quite challenging. The other thing is that you're exposing everybody's IPs to everybody else, and people do DDoS each other. These are all things in the public domain. These things happen in real life. So there's a conscious decision by Respawn to go with dedicated servers. The real advantage of peer hosting is that it scales with the player base. So as more players join, more people are being the hosts. So it's actually, that's the only real advantage, and it can be good in a co-op game. People tend to grief each other a lot less. So as an example, A Way Out is peer-hosted. One of the consoles is hosting for the other player, but they're both cooperating together. There's only 2 characters, plus objects other objects in the world that are replicating. So it's very light. It doesn't cause a strain on the engine to deliver that. So it was essentially decided dedicated servers just give a better experience, full stop. And I think that's something that over the years we've just stick with. If you look at a lot of EA games, they are hosted on dedicated servers. The key thing as well for Titanfall 1 when they set out was they wanted it to scale automatically, which created a challenge back in 2013 when we started looking at this project. I think we were the first game to automatically scale in the cloud. And that was very, very challenging at the time. It's broken the ground for a lot of people since. The other thing to mention is that Titanfall 1 and 2 shipped with Windows binaries for the dedicated servers. That has a cost implication, which we'll come on to later. And the key thing, Respawn have this system at the back end called Strider that controls it all. This is a kind of block architecture diagram of all the different components. Strider sits in the middle. It's doing the matchmaking. It's doing persistence, so player data. Again, one of the reasons for doing dedicated servers is a security model. In Titanfall, the client is truly dumb. It is just passing controller input to a server. The server is completely authoritative on everything. It makes it a lot harder for people to cheat, which is a good thing. The client also never controls their own data. The dedicated servers read and write the persistence, so you can't tamper with the number of headshots you've made, the number of kills you've had, because the server is completely in charge of that at all times. So that's the persistence element. We've got community pieces, networks, people talking to each other, etc. It's slightly more complicated than some EA games, but also slightly less complicated than others. In the bottom right-hand side, you'll see the cloud scaling bit. The green bit is Multiplay, talking to that, scaling those up and scaling those down. In the top right-hand corner, you'll see there's an EA TechOps piece. When we started Titanfall, we were the first customer for Multiplay on console. Titanfall uses a lot of EA tech, and it also uses first-party interfaces for console. And we have more visibility into that with all the games that EA is publishing. So we have a tech ops team that run 24/7 and work with the Multiplay team to make sure that everything's running smoothly. Both of them work to spot outages as quickly as they can. There's kind of competition between the two. So we notice things going wrong very, very quickly, and we can fix them very quickly. So that's kind of a rough block architecture diagram of. So in 2014, when we shipped, we used Microsoft's Azure, something called Thunderhead, shipped successfully, and then we switched to a mix of bare metal and multiple clouds in 2016 with Multiplay. I'll explain why, I'm going to give you some background to that in a minute. What's the difference between bare metal and cloud? I know this is kind of repeating Will's. They're all just servers in racks. There is no difference. On a technical level. However, on a business level, they are different. If you want to reserve bare metal, you have to book it way up front. That can be months, depending on the scale of the order that you're making. As Will said, it's fragmented, different providers all over the world. So that's not something we wanted to get into. Cloud, you purchase the server by the minute or the hour. I would also say, as Will kind of hinted at, actually bare metal, there is one difference at a technical level. Bare metal is less resilient to DDoS attacks. Cloud is very resilient. It's their real core business. We had, before the attack that Will talked about, we had an attack in a tech test where they hit they hit us deliberately, and you do get large games where they target you, and they announce that they're going to target you, which is even more fun. They targeted Titanfall in its tech test at a data center. We moved that capacity to another data center. they followed us and attacked that second data center, and we moved that capacity then into cloud, and they stopped following us at that point. That was all done within kind of 10 or 15 minutes. A lot of the community didn't know what was happening, didn't see it. We saw it on all the graphs, etc. And then that led to changing the process so that we were able to do that on the click of a button if we ever saw it in the future. When we launched, we were affected, as Will said, by a side effect of somebody else being attacked, but we moved it very, very quickly at that point. One of the key things about Titanfall as well is that for gameplay purposes, there's three things that contribute to kind of the quality of the gameplay experience. One is ping time, so how smooth, how much latency is there? If you can get servers local to the player, so your ping is sub 50 milliseconds or less than 100 milliseconds, it creates a better experience. It's less laggy. Titanfall's got some amazing tech in there that actually compensates for a lot of the lag, but so it feels really smooth, but you can, if you get up to 200 milliseconds plus, you end up with bullets missing and things like that. There's only so much you can compensate for. So again, one of the key things that Slothy and Respawn had on their agenda was get servers as local as possible. So we launched Titanfall 1 with 10 data centers around the world, 4 of those in the US, 3 in Europe, and 3 in Asia. We launched Titanfall 2 with 10 data centers in slightly different locations because we changed providers, but similar kind of makeup. That's to get the latency low. The other two things that contribute to quality of the game are, is it challenging? People do like to have challenging matches where they feel they've come out on top. So that's a mixture of how your matchmaking works, trying to get people of similar skills together, which is incredibly difficult. And the other thing is getting into matches quickly. If you're sat in the lobby waiting, it just takes away from the whole experience. You don't want to spend more time in the lobby than you do in the game. And that's something you have to balance out between the quality of matching people together, because it takes time to put people in the right buckets, versus how long they're spending matchmaking. And it's very tricky to get right. So in terms of bare metal, as I've said earlier, it can take weeks or months to order. We have teams in EA that work on we're called demand planning, that work on our estimates. They're pretty good at estimating. No estimate that we ever make is correct. They're all guesses. They're varying degrees of wrongness. And they get reasonably close. But one of the things, as Will said, is you kind of don't want to get it wrong. So in the bare metal world that we used to live in, if you under-ordered and you have too many people turn up to your game and they can't get onto a server, they leave very, very quickly and never come back. And by the time you've got the additional hardware in to support that player base, they're on the next game. And the sentiment in the market is terrible. That's happened many, many, many years ago, and that's not something that you ever want to repeat. As a result of that, what you tend to do is you overcompensate. You estimate too many people coming to your game, so you order too much bare metal, and that's a cost. And because you're ordering bare metal on a monthly basis, generally, to get it cost efficient, you can be left with quite a sizable bill. This is not Titanfall. This is another EA game that all the numbers have been removed. This is about 100 days worth of what we call peak PSU, peak simultaneous users. So the number of people playing at the same time. Those first 2 peaks are about 2 weeks. So after 2 weeks, you can see it drops to about 50% and then maintains 50 to 40% of the player base oscillating. I can guarantee we ordered significantly more hardware than was needed to support this player base. And we had it for at least the first month. That's a cost. This is a graph from Titanfall 2. What you see here is we had a couple of... and again, one of the things... if I go backwards. One of the things about these is we've gone at launch on a AAA title from 0 players to several 100,000 in 24 hours. you're creating a massive pressure on all the systems to be able to support that. Similarly, Titanfall 2, different scale graph. On this graph, you'll see our launch. It's settled down a little bit. Then around December, when we dropped some DLC, everything picked up again. We get one spike. Then at Christmas, which is typical with many AAA games, everybody seems to go and hide in their den and play games Christmas, Boxing Day. We get a massive spike again. We doubled or trebled our player base because it had settled just before Christmas. Those, if you're in bare metal, which of those are you trying to buy for? Given we launched in October, we would have probably had to keep bare metal around for the whole of November and December just in case, because we would have known that something was coming at Christmas. Being in the cloud lets us scale. You also get massive spikes after Super Bowl games, and also you get massive spikes if another first-person shooter goes down and people can't get on it. So those things are all compensated by the cloud. Coming back to, we had 10 data centers. This is a daily graph from, or it's several days, of daily graph from the different data centers. You'll see there's a variation. Your game will not be equally popular and have the same population in Asia as it has in Europe, as it has in America. So when you're trying to predict, and remember, it's varying degrees of wrongness, but when you're trying to predict, depending on the number of data centers, for each of those data centers. How many people are going to turn up in Singapore? How many people are going to turn up in Europe? How many people are going to turn up in West Coast America? You can push some people around without increasing latency too much and making their experience suck, but you've got limited capacity to do that. You'll see some of those populations, like the brown ones, go to 0. Even the blue ones, some of the blue ones go very, very low. So you get massive swings on every day. And you can probably work out which regions of the world based on where they're aligned there. But your population changes throughout the day. Those contribute to that blue curve, because that was measuring worldwide. This is actually in the local data centers that we had. So we had 10 of these. Again, cloud helps us with that. So our solution to making people able to sleep at night is to have this hybrid model. We can burst into cloud during peak times, and we use bare metal in non-peak times. The bare metal helps us control our costs, because cloud is expensive. We pay for bandwidth, which you get an allocation in your bare metal. We don't tend to use any of that we don't tend to go out of that on a monthly basis and have any bandwidth costs in bare metal. But in cloud, we're paying for every bit that we transfer. We're also paying for Windows licenses. So this has allowed people to sleep at night. And what we found on Titanfall 2 is if we need an instance for more than 4 hours a day in cloud, it's cheaper to run on bare metal. I'll talk about the launch, how we work in launch, and how we optimize in a second. So this is essentially a very simple diagram. Green is bare metal, and the blue above is when we're bursting into cloud. We kind of optimize the layer of bare metal to make sure that we're not bursting into cloud too much and it's costing us too much. Why do we use multiple clouds? You'll have seen in the architecture diagram, we had multiple cloud providers in there. Respawn have run out of servers twice in 2 launches, one in each launch, with cloud providers. It is not infinite. People like to tell you it is, but it is not infinite. You do have to do some planning with the cloud providers, but it's less than you have to do on the bare metal, because they are much more responsive. This is the kind of process that EA uses internally. So pre-launch, we forecast, get it wrong, reforecast, get it wrong, measure things in the market, get it wrong. It gets more accurate. Part of the problem is that by the time you're getting good figures for ship, you are past the point where you need to order the bare metal. So as you're getting a few weeks out from ship, you have more certainty with orders from stores, etc., market sentiment, comms channels, but it's kind of too late for bare metal. Again, that feeds into why cloud helps. What we do, you saw the architecture diagram, we prove out the scalability of each subsystem. They all interact with each other. We want to make sure that none of those break at the forecast that we're expecting. So we test the subsystems, we find out where they break, we test the overall system, find out where that breaks. If it's below where we need it to be, we fix it, and then we retest. And that includes making sure that the number of servers, instances that we expect per physical piece of bare metal or per cloud server is the right number. So we work with Multiplay to make sure that we don't have bugs introduced that cause CPU or memory spikes that reduce the number of instances that we can run. They monitor our mean time between failure on server crashes, because, again, quality of experience is dictated by how stable your game is. So we work with them to make sure that that part of the system works really well and can scale. On Titanfall, again, because we were the first customer of ClanForge's cloud scaling, we tested to 1 million players regularly, just scaling up as quickly as we could. Wasn't as fast as the demo in the keynote speech the other day, but this was a few years ago. But it gave us the confidence that we could scale up if we needed to. And we use QA, we capture logs to see how they're playing the game, we replay those, we write scripts, we replay those. Again, like forecasting, it's never right. QA people don't play the game the way real players play the game, so the only way is you run a technical test or you run a beta. And real players then come in and you see how the system behaves and reacts, and you fix everything in the background. So for EA, launching a game is a very serious business. Lots of years ago, we had some failures, and we never want to repeat those. So we try and make smaller mistakes on every game. We have, around the launch period, a couple of days before through to about a week after, we assemble what's called the War Room, which is all the key people that are involved in shipping the title. All their departments are represented either in person or on Slack, so that when we launch, we spot something, we can jump on it straight away and try and fix it. Part of that is the game team, part of that is the ops team, tech ops from EA, comms channels, our customer support people, Multiplay, everybody's represented. We all sit in a room together, and we monitor, fix things in the background that inevitably come up, and we refine the processes for post-ship. The best war rooms are incredibly dull. Fortunately, I've been to a few of those. You play the game lots, which is cool. You watch lots of Twitch streams of your game, and there are no problems to solve. It is unbelievably dull for 16 hours a day. But they are the best ones. What you don't want to be is so busy trying to firefight that you can't think. As interesting as that can be individually, it's not good for the community. Post-ship, it's still a 24/7, 365 operation, as Will said. One of the reasons we moved to Multiplay was the level of support we got on that side of things. As I said, we have a small ops team, or Respawn have a small ops team. One of their guys, Mike Kalis, who's an absolute star, didn't get much sleep after Titanfall 1 launched. He was pinged lots and lots during the night. We've had 2 instances in the last 20 months on Titanfall where Mike's been called. One of them was a bug in Strider that he fixed, and the other one was to consult on something that needed further investigation. Multiplay ops team and EA's tech ops team, between them, solve 95% of our problems before we need to wake anybody up. And the community doesn't notice those because of the monitoring that's going on in the background. And the other thing that we work with Multiplay on after ship is optimizing processes and optimizing the buffers that we have, that we carry, et cetera, for cost, to just optimize everything as much as we possibly can, get great server efficiency, not carry as many servers, et cetera. But it's been pretty smooth on Titanfall 2 since we shipped. And I thought I'd almost end. This is one of my favorite images from when we launched Titanfall 2. It's, Will, you probably need to explain what the different colors are, because I can't remember. I like the yellow bit.
Yeah. Can I get some mic?
Oh, yeah, new mic.
Sorry, sound desk. Can I have some mic? Hello? Right. So just to quickly explain, I'll go through this graph. So you have the green line here, which is kind of your consumed resources, the light green line. Your darker green line is kind of what's online and running, and your blue line is what exists, what is created. So you can kind of see as we kind of scale up in the day in the region, we start turning on a few servers. The dark green line meets the blue line. Then as the CCU for the day kind of gets towards hitting that, you can see that we're in very kind of granular fashion. We're just making a couple more VMs, a few VMs every minute, just kind of scaling it up, hits the top of the curve, and then the dark green line comes down as the lighter green line comes down as well. And the yellow line across the bottom there is just how many servers we're starting at any one point. So you can see just a couple every now and then just to kind of keep the scale going. And most importantly here, you can see the dark blue line, it stays high. So what actually happens with cloud is that, particularly with Titanfall, it's more cost effective for us to sleep the server overnight. So by that, I mean just shut down rather than destroy the VM, than it is to come and build a new one every time. So since we think we're going to use the VM the next day, we just leave it slept. You're only paying for disk at that point, so you've reduced a lot of the cost, and it's ready next for the next day. And the flatness of that green line is how much bare metal exists in that region. So you can see it bursting through the bare metal, coming up into the cloud, and then kind of tailing off towards 1, 2 a.m. as the players are not using it.
Can I get Mike back, please?
Yeah, and we'll swap back to Fred for his mic.
Hello? OK, cool. Briefly, we did some architectural changes when we learned some lessons on Titanfall 1. Respawn are very, very good about learning lessons and acting on those lessons that they learn. So Titanfall 1, we tried to keep as many players on servers as possible for as long as possible, keep people together. The idea would make a better gameplay experience. Actually, that turned out not to be true. Keeping people around too long, if they get into a bad match, the unbalanced teams, etc., they tend to quit anyway, and that's what we found was happening. So we adjusted the matchmaking over time, so that it didn't keep people in matches as long as it could. One of the key things we did on Titanfall 2 as a result was after every match that the player has, they actually go back into the matchmaking pool. That helps us defrag the game server universe. There's two things that work there for us. It allows, by throwing the servers back to Multiplay, they can defrag on their side and we can bring that curve down, because it's, as Will said, bringing the curve down is the hard bit. But also, it allowed us to defrag the skills. So we were able to match players better. So players don't know they're doing this, but they're being thrown back into the matchmaking pool, and we're trying to see whether we can get a better match for them to play on the next time. If you want to see John's previous talks, they're all both on YouTube. There's a talk that he did at Rackspace, and then there's also the talk he did last year at GDC. And we're now open for questions. Yep. If you have a question, please use the mic. Nope.
Yeah, there you go.
Hi, hello. I have a question about the netcode and the data compression that the Multiplay is using. So, like, how possible it is to make it like 30 frames per second for the netcode?
So for netcode in Titanfall, it was Respawn's netcode. So I'll let Fred answer that.
Titanfall 1 and 2 are based on a heavily modified version of the source engine. Respawn got that in 2010, and it's now 8 years later. So it's heavily modified. One of the stacks that was modified most heavily was the networking stack by Slothy. The game, it is possible to run, so the game simulation on the servers runs at 60. We send packets at 20. So it is very possible to make it run fast. Titanfall, that's Titanfall 2. Titanfall 1, I believe, was 30 and 10. So we doubled the frame rate as part of the optimizations and part of the learnings to make a smoother game for Titanfall 2.
Okay. Thank you.
Okay. Any more questions?
I'm more than happy to have one-on-ones outside if people have any questions later as well.
Hi, thanks for the talk. Can you estimate what will change with the new cooperation with the Google Cloud and Unity coming up?
Yeah, sure. So one of the key things here is that obviously all of our talk today is talking all about AAA games, right? So whilst I mentioned we do work with smaller studios, one of the things that we really want to work with Unity, kind of as part of our partnership, is bringing that out to a wider audience. So you saw some of the tech in the keynote that we're hoping to kind of bring along, but you'll hear quite a bit more from Multiplay and Unity on that kind of later on in this year. Any more questions? As Fred says, we're more than happy to kind of answer questions outside, or by all means drop us an email, drop us a tweet, whatever that might be. But I think we're all good. So thanks everyone for coming.